We're comparing when two different colored lights go through this prism. If it was red light, then it would start here, and it would refract here, and then come through here. And if it was violet light, then it would refract twice and come out through this angle. So we're going to compare the difference between those two angles, and it is going to refract twice, once on this side, once on that side. Now they've given us the index of refractions of these lights inside the prisms, and they've given us the angle of incidence right here. So that's when we draw our normal, and we get the light coming at this angle. Now we want to be able to figure out sort of one of these things at a time. So let's start with the red light. We're going to redraw this, and we're going to say, okay, so the light's coming through here, and it's going to be coming off that angle right there, and we'll just focus on one piece at a time. So we're getting this angle to be 47, and then we could figure out this angle. So let's figure out what that angle is real quick, because that would just simply be the n of the air times the sine of the air is going to be equal to the n of the red inside times the sine of the angle of the red inside, which would be this one right here. If you know that the n air is just going to be 1, we could take the sine of 47. That's just going to be equal to 1.62 sine of that angle. We could divide this by 1.62 and essentially just take the arc sine of both sides, and we'll be left with the angle that's inside of here. So we'll just say the arc sine of the sine of 47 divided by 1.62. So we get an angle of 26.84. So that helps, but it's not going to be really the angle we want, because what we have here is we have this prism, and we happen to know that this angle is 60 degrees. So we kind of want to get a little bit of information about this angle over here, which is going to help us later. But let's try to get this angle first. So it would be 90 minus that answer that we got, because that's just a 90-degree angle there, right? So this one's going to be more like 63.163. And now we could take this angle, because that would be 180 minus the answer minus the 60. So now we're over here at looking at this 56.83. But here's the thing. That's not really the angle we want. And what's going to happen next is that this light, we want to find our normals first. Here's the normals. And it's coming at this angle here. And that's going to be refracted one more time. So we're almost done here. We kind of take it in like 2 steps. So now we have figured out this angle was about 56.84. But we need this angle because this is the angle that comes from the normal. So that would be 90 minus that angle. So 90 minus the answer. So this angle that's more interesting is 33.163. And now we can set up our equation one more time, because n of the red and the sine of that red right there that we have is going to be equal to the n of the air times the sine of the air. This would be for the red. We'll keep track of that. So this is just going to go with 1. And we would have the n red, which is 1.62, times the sine of this new 33.163 is going to be equal to the sine of the angle that we're really trying to find over here. This one. Bam. Okay. So now, let's just solve for that. We do 1.62 times the sine of our angle, and then we could take the arc sine, and we get that this whole theta red is 62.39, 7 or something. So we kind of have one of our angles. All we have to do is repeat this process for the violet and then figure out what the difference is, because this is now the angle we have here, 62.4. So let's sort of redraw this real quick. Here is going to be the beginning. This is our n. This is how the violet light comes through. Remember that this is supposed to be 47 degrees. And then it's going to curve off in just a little bit different angle over here. Eventually it's going to hit this side. We know this one's 60. And we can calculate this one by using our n's. So that would be like n of the air times the sine of the air is going to be equal to the n of the violet this time times the sine of that violet angle inside. This is just going to go to 1, and this one is going to be sine of 47 equals, the n violet was just 1.66 that was given to us before, and then the sine of this angle that we're trying to find. So let's go sine of 47. Then we could divide that by 1.66 and take the arc sine. So we get that this little angle here is 26.14. And then we could just subtract 90, because remember that this is a 90-degree angle here. So 90 minus the answer, 63.86 on this side. Let's take the 180 minus those two angles. 180 minus that. That becomes 56.14 on this side. Let's redraw this one more time. We're going to have our normals like this. And we'll take our light that's coming through. That's going to be refracted just a little bit more over here. And this angle we know to be 56.14. This is supposed to be 90, so we're really close to getting that one. 90 minus the answer is 33.86 on this side. And now we can just take the n of the violet on the inside times the sine of that angle on the inside is equal to the n of the air times the sine of the angle in the air. That would be this one that we're trying to find. So we're really close to getting that. This is, of course, just 1. And we have 1.66 sine of our 33.86 equals the sine of theta. So we'll just go 1.66 times the sine of the angle we found. And then we'll take the arc sine. So we find that this angle is 67.65. That is the angle for violet. 67.65. Now let's remember that our angle from the red was 62.397. And all we're doing is trying to calculate the difference between those two. So it would just be 67.65 minus 62.397. And, well, delta angle is going to be equal to 5.253. So that would be what we're looking for.